I use a level and a straight 2x4 to mark the location for the top plate on the underside of the joist. I do this at both ends of the wall and then snap a chalk line between them. I nail the top plate up into the joist along this line. Now I'm ready for the studs. Since the flooring and the ceiling might not be straight and level, I measure the studs one at a time. I set the 2x4 on the bottom plate, mark where it crosses the top plate, and cut it off at the mark. Then I hammer it into place and toenail it into the plates. I'm using 2x4s for this wall. A 2x4 wall is easier to insulate and install electrical in. But a 2x4 wall does eat up a little bit more floor space than a 2x2 wall.
Alright, we'll do it again.
If you need to build non-bearing interior walls, you might be able to build these on the floor and tip them up. Build them about a 1/4 inch short so that there will be just enough clearance to tilt them into place. Even when they're built short, they still may need a little persuasion in some points to get them plumb.
Just take a shim.
At other points, you may find yourself filling in with shims between the top of the wall and the underside of the joist. Where interior walls connect with the outside walls, you'll probably end up having to put some wood blocking between the studs to have something solid to attach the interior wall to.
There we go. Now this wall isn't as long as the other one, but it is actually a bit heavier because we have openings in here for doors. And openings require headers, and headers make everything a little bit top heavy. Okay, I'm going to get the ladder.
There you go.
Now let's get back to our main project and see how we install the second floor platform.
Are the joists all set?
Yep.
Okay. Well, we're pretty much at the point now where we can start putting joists up here for the second floor. This board right here is the rim joist. This is what all the joists coming across here will end up butting into. You want to go ahead and hand one of those up here, Mark?
Sure.
And you notice we have all of our joists lined up, so they'll be right on top of our studs. Okay, Robin, you set?
Sure, got it.
Over the top. All right, if you hold that down, I'll go ahead and nail this in.
Okay, it's right there.
Ready, Robin?
Yep. Whoa.
Coming at you.
Okay. It's about a 24-foot span for our joists across the addition and over this back stoop. Since we've got this wall here, we can use 2 shorter pieces of lumber and join them together in the middle. Okay. Once we finish the subfloor on the upper level, we could turn our attention to the roof. Most roofs nowadays are constructed using roof trusses. The first step is to mark the positions for the trusses on the top plates of the walls. Trusses are usually spaced 2 feet on center, but your architect or truss fabricator will probably supply a plan showing the exact position for each truss.
Okay, up on the other wall there. Our addition here has 2 different roof systems. We're going to hand frame this little area over here, and then over the family room we'll be using trusses. Now you'll see how fast roofing goes when we're using trusses. I should go a little bit faster if we had 4 people, but unfortunately our budget only calls for 3, so Mark's going to be helping us out here on most of the framing. Okay, up we go.
1, 2, 3. Big swing up. There you go. Now that wasn't so bad, was it? We put these planks on the inside walls and this aluminum one down the center to stand on while we're working on these trusses. It's worth taking the time to set something like this up. Otherwise, it's too tough moving these things around. So now we're going to position these into place and toenail them into the top plate of the wall. Okay, ready?
Yep.
Let's go. Okay, you just let us know if we're going too fast for you, Mark.
No, I'm doing fine.
Keep it up right there a little bit more. What are we doing, Mark?
Good.
Now we're going to have to go a little bit higher to get over our brace down there at the end, all right? Now many times you can just toenail on the base of the trusses and they'll stand there by themselves. But ours are a little bit top heavy, so we've thrown in a couple of extra braces up there on top. Now what we're going to do is run a long brace all the way across the roof as we install the rest of the trusses here. Mark, you going to lay out that 1x?
Yeah, I've got it ready.
Okay. Okay, let me get this nailed in right here, okay?
Okay.
Right there. That's right. I could see how a guy could really nail a finger on this one. There we go. Okay, that's in. I guess we can get the rest of these in here then, huh?
Okay. Okay, come my way a little bit.
Okay, right there?
Yep, there, I'm flush.
All the braces that we've installed so far have been temporary. They're just to keep everything from not getting out of kilter. But the braces we're installing next are permanent. They actually slide in between the trusses. I'll end up taking the temporary ones down. We want to leave them up as long as possible. We'll probably remove them once we do the roof sheathing.
Once the trusses are all in, you need to cut the ends off to the right length. This dimension is determined by the size you want your soffits to be, and it's going to be different from house to house. You use a level to draw in a plumb line on each rafter. Then you cut it off with a circular saw.
Trusses are so quick that the roof on this addition went together pretty fast. Hand framing, which we had to do on the older part of the house, is a lot more complicated and takes longer. For example, on this project, we started off with a lot of demolition to make way for the new roof.
Then we installed a heavy ridge beam. This is always a tricky operation. We temporarily put up 2 pairs of rafters and then hoisted the beam up between them.
Here we go. How you doing there, Robin?
Good.
The beam is nailed to the old ridge beam on the house and to the tops of the rafters.
Here.
In this situation, we also have to support the end of the new ridge beam with a header over the opening at the top of the staircase. The framing for our valley is sort of unusual. It's 3 laminated beams with special angle cuts at each end to get them to fit right.
Generally, roof framing is full of special angled cuts. Often, the framing tools can help calculate these. For instance, you can use a framing square to calculate the jack rafters, which run from the ridge into the valley beam. Use the 2 sides of the square to recreate the 10-12 slope of the roof so that the top of the jack rafter will sit flat against the ridge. Also, there's a chart on the framing square which tells you how to angle the cut at the bottom of the jack rafter, depending on the slope of your roof. So we got 12 here and 9 and 13/16 right there.
Compound miter marked. Great.
For the bottom cut, the saw needs to be set at 45 degrees, which makes this a compound miter cut.
The final framing step after roof trusses and rafters is to install sheathing on top. Let's see how that works back on one of our other projects.
Nice. We're sheathing the slope part of the roof first and working our way around the corner before we start in the flat top of the roof. Now we want the first piece of sheathing to go on flush with a fascia board here that we'll be adding later. So we're marking exactly where the first sheet should go now. All right, so one board here represents a fascia, and this board the sheathing. We'll mark this one, and then measure up 48 inches, which is the width of the plywood. Okay, you got it there?
Yep.
Then we snap a chalk line over the marks along the entire slope. That'll guide our first row.
The 4x8 sheets go lengthwise along the trusses, and we secure them around the perimeters. We'll nail in the middles later. With the 2-foot centers, the edges of a full sheet will fall right over the trusses for easy nailing. You don't want the corners ending up between the trusses.
Our last piece in this row is going to carry out over the hip ridge, so we want to cut it off along this angle before we put it up. And to do that, we measure out along the bottom. You got that there? Yeah. All right, that's 60 inches. And then measure along the top here next to the chalk line. All right, that's 10.
We transfer the lengths to plywood and snap a chalk line between them. Then we cut the corner off. We lay the sheet in using the chalk marks as a guide. Then we nail it in.
The third sheet in the first row lays in against the valley board. It's angled, so we have to measure the sides and cut a sheet to fit. Then we nail that into place. And with the first course done, we then nail down the middles of the sheets. Once we've secured them, we nail in a 2x4 cleat a couple of feet up from the sheathing. That'll give us safer footing as we continue up the 45-degree slope.
We're putting these clips on the edges of the plywood to strengthen the joints between the first row and the second row of plywood. We're putting them in every 2 feet or so between the trusses. We put in the second row of sheathing using the same techniques. But we do start this row 4 feet over from where we started the first row. That staggers the seams from course to course, which increases the strength. As on the first row, we do cut pieces to fit the hip and the valley.
All right, 26 3/4. Now the third row of plywood gets cut off lengthwise. This way it lines up evenly with the top of the roof. Other than that, the installation is pretty much the same. Here on the flat part of the roof, we'll increase the thickness of the sheathing to 3/4 of an inch. It'll give it just a little bit more strength. Since a roof here is flat, installing the sheets is a lot like covering the first and second floor platforms, but we use extreme caution here because of the height involved.
Well, we hope that by watching these projects with us, you'll have a good feeling for the tools, materials, and techniques of basic framing.